Okay, welcome back to Math Explained. The topic of this video is the quadratic formula. Okay, so we've been factoring, and we've been factoring quadratic equations. Well, quadratic, if you recall, are the ones that have as their highest exponent a 2. So ax squared plus bx plus c. That's our generic form. So okay, so let's say we have this. So we have y equals x squared plus 5x plus 6. This one's factorable, but I just want to show you that the quadratic formula works. So most things, if you can factor them, a lot of times we would just factor them. But some things don't factor nice and neatly. So say you have 2.5x squared plus 1.38x, stuff like that, we're not going to factor. So if factoring won't work, and also if you have something like this, where your quadratic is up here, it doesn't cross the x-axis at all. It has solutions, but they're not real. They have square roots and negative ones in there, but we'll get into that. So okay, so we have this one. This one is factorable, but let's apply the quadratic formula to it. So to do that, first of all, we need to know the generic form, which is y equals ax squared plus bx plus c. This just tells you that a, b, and c are numbers, and we're going to look for those in anything that we're trying to solve. So in this case, our a is a 1, our b is a 5, and our c is a 6. Okay, that's important. So the basic quadratic formula is this. X equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So this is really, it looks like one equation, it's really two, because we've got the plus or minus in there, right? So this is really, you're going to have two answers. Our x1, I'm just going to copy and paste this, is this, only I'm going to subtract this. I'm going to make this a positive. And my x2 is the same thing, only instead of adding, I'm going to subtract. Make this a little bit smaller because I ran out of room. There we go. Okay, so this one is now, instead of plus or minus, it is just minus. So we're really looking at two different things, right? It's the same, it's one equation, but really it's two because we've got the plus or minus in there, which makes sense because since my highest exponent is a 2, then I have two possible solutions. Okay, so let's get into applying this. Okay, so I like to apply things in pieces because that, like just looking at that, that's a whole lot of numbers to put into places, and this is, I know I'm going to mess this up. So what I do is I split it up. Let's see here. I'm going to go over here. Okay, so this is my quadratic formula, so x equals that. What I do is I like to split it into chunks. So this is really, if I split this up, it's a fraction now, but I can actually kind of, because I've got the plus or minus, I could put it into two pieces. So this is really negative b over 2a plus or minus all of this over 2a. Same thing, I just put that over that and that over that, right? So I didn't really change much. So then what I do is I can solve it in parts. The first thing I do is I come in and I find my negative b over 2a. Right? So we'll just say that's whatever I got for that. The next thing I do, I actually kind of break this one up a little bit too, just because there's a lot going on. So the first thing I do is I find the stuff that's going to go under my square root. So b squared minus 4ac. Let's say that's, we'll call it a pumpkin. There we go. Ta-da. And then my final step on that part is I'm going to square root my pumpkin, divide it by 2a, and let's say that gives me triangle. So then my two answers, x1 and x2, is I'm going to take whatever I got up here, my little cloud thingy, plus whatever I got in a bottom step. So plus my little green triangle. So this is my triangle. So then over here, it's the same thing for x2, except it's those and I'm subtracting them. Ta-da! Put my equal sign and let me change this plus to a minus. Okay, and you're like, what in the non-negotiable is this? This is the devil's work. This is not math. This is a bunch of letters and shapes and something is just wrong. Okay, so let's use our example. So I have y equals x squared, or f of x equals x squared plus 5x plus 6. So I already said my a is a 1, my b is a 5, my c is a 6. Okay, so I said that, well here, let me copy the whole quadratic formula over so we have it. Just as a reference, right? We'll put it up here in the corner. There we go. So my first thing that I do is I do negative b over 2a. Well, my b is a 5, so negative 5 over 2 times 1. That's just negative 5. Okay, that's not terrible. Let me put a cloud around it, because that's what we were doing a minute ago. Okay, so I'm going to use that. The next thing I do is I take the stuff inside of the square root. So b squared minus 4ac. So this is going to be 5 squared minus 4 times 1 times 6. So this is 25 minus 24. So that just equals a 1. So that was my little pumpkin, right? Ta-da! So now I'm going to square root that. And I'm going to divide that square rooted part. So square root of my pumpkin divided by 2a. That looks like a Greek letter, but it's really supposed to look like a pumpkin. Okay, so then I'm just putting this in there. So this is the square root of 1 over 2 times 1. Okay, so this is 1 divided by 2. Okay, and up here I forgot my little 2 right there, sorry. That was probably confusing. So okay, so that's my little green triangle. So then my 2 answers, I'm just going to use this one, then this one, right? So x1, I'm just going to take what I got in my yellow cloud, so negative 5 over 2, and I'm going to add it to the bottom one, which is 1 over 2. So negative 5 plus 1, that gives me negative 4 over 2. So my x1 is negative 2. Okay. Then for my x2, I do the exact same thing. Only, so I have negative 5 over 2, and now I'm going to subtract. So minus 1 over 2. That gives me negative 6 over 2. So my second x is negative 3. So that's how we apply that. Now I like breaking it into chunks like that because I have less of a chance, or a lower chance, of making mistakes in my calculator. Because if you have to put all of this stuff all at the same time in the calculator, it's really easy to not put a parentheses where you should and accidentally divide by something else that you shouldn't. I just like to break it into pieces because it makes it easier to solve. Now you can get into funky things, like this actually had nice, neat solutions. But you can get into things where you have square roots and negatives and that kind of stuff. And that's totally fine. Those are valid answers. But this is why you use the quadratic formula, is because if you had square roots and negatives, those are not going to be factorable. Okay. Hooray! So basically, you just take whatever you have for your a, b, and c value, and you just plug it straight into this. Ta-da! And that gives you both of your answers. But like I showed, I like to split mine up to make it easier. But you get the same thing. Hooray, quadratic formula.